staying put. It's the science of stability, of things being held perfectly in place, which is pretty important when you think about it. Imagine a book resting on a table. It's not going anywhere, right? It's just sitting there. Statics helps us understand the invisible pushes and pulls that are keeping that book exactly where it is. It's not magic, it's science. We study statics to make sure the world we build around us is safe and sound. From the chair you are sitting on to the roof over your head, the principles of statics are at work everywhere, all the time. It's the silent, unseen hero that keeps our world from falling apart, ensuring that things are strong and stable. Think about a game of tug-of-war where both teams are pulling with the exact same strength. The rope in the middle doesn't move an inch. It's in a state of balance. That's a perfect example of statics in action. We are looking at all the forces involved and seeing how they cancel each other out to create a state of stillness. Scientists and engineers use these ideas to design things that need to be incredibly reliable. They want to make sure that a building, a bridge, or even a simple shelf can handle all the pushing and pulling it will experience in its lifetime without any unexpected movement. So, when we dive into the world of statics, we are essentially becoming detectives. We are investigating the secret forces that are constantly at play on non-moving objects. We learn how to calculate these forces and predict how objects will behave under different kinds of stress. This knowledge is what allows us to build amazing structures that can stand for hundreds of years. It's all about understanding balance and making sure that for every push, there is an equal and opposite push keeping things right where they should be. It's a fundamental part of physics, and it's truly all around us. To understand statics, we first need to talk about a key player force. A force is simply a push or a pull on an object. When you push a door open, you are applying a force. When you lift your backpack, you are applying a force. Even when you're just standing still, the force of gravity is pulling you down toward the center of the earth. At the same time, the floor is pushing back up on your feet with an equal force. These forces are everywhere, acting on everything, and they are the main characters in the story of statics. We measure forces to understand how strong they are. Now let's talk about balance. In statics, we call this wonderful state of balance equilibrium. An object is in equilibrium when all the forces acting on it are perfectly balanced out. Think back to that tug-of-war game. If one team pulls harder than the other, the rope moves, and it's no longer in equilibrium. But when the forces are equal, the rope is in equilibrium. The same thing is happening with a hanging traffic light. Gravity is pulling it down, but the cable is pulling it up with the exact same amount of force. The result? The light stays put, perfectly balanced. Let's consider another everyday example. Imagine you and a friend are trying to carry a heavy couch. If you both lift with the same